Right, good morning everyone, I'm Mark Hemmant, I'm a technical manager at Agravista. It's my great pleasure to welcome you to the last day of filming at Project Lamport for this year. What we're going to do is Neil and myself are going to take you through the blackgrass aspects of Project Lamport quite briefly. We'll then pass on to Chris Martin, our Head of Soil Health, who'll talk about the soil health aspects of Project Lamport, which are very important. And then finally we'll talk to David Purdy and Philip Bright, who'll talk about the work they're doing on the site. And then most importantly, we'll then hand over to you to ask all the questions that you want to ask us. So this plot really exemplifies why we set up Project Lamport 7 years ago. Chemistry was failing and we had to find a way to allow farmers to establish reliable spring crops. And this really shows it perfectly. We've got a winter wheat here where we've delayed sowing. We know we have to delay sowing. We've put 130 quid's worth of blackgrass chemistry on it. We've stacked residuals and we haven't controlled the blackgrass sufficiently. We've probably got a reasonable percentage control, but with the weed seed burden here, we have a huge amount of blackgrass left. And of course this year, with the difficult autumn we've had, not only that, but on farm we've either not drilled our winter crops, or in many cases we've drilled them and they've ended up in a poor state full of blackgrass. So this is why we really had to set up Project Lamport.
Well, following on from the plot that Mark's just demonstrated to us, we've seen the levels of blackgrass in that plot and realised that we can't continue as we have done. So looking at cultural control techniques for blackgrass control, one of the big hitters is spring drilling. So we set out with this plot here that once we'd harvested the previous crop, we've come in here, we've carried out a cultivation to get it set up ready for the winter time. We've had quite a lot of blackgrass coming through the winter, but what we've observed through the winter time is particularly with this plot here, because there was nothing growing on here except for blackgrass, we've had quite a lot of water and puddling, particularly in the autumn and winter that we've just experienced, and even had some runoff through the winter time. And as a consequence of all this water coming down, much of the soil loosening that we did last autumn has actually got washed together, or the fines are washing down where the legs have been going, and it's all sort of run together and actually sealed over the surface, quite a lot of it. We've then got through to springtime. We sprayed everything off with glyphosate, so from a blackgrass point of view, we'd done everything that we could at this point, or we thought we had. We then came in with a direct drill, and it drilled quite nicely at the time, although you do tend to notice that there was quite a bit of soil movement going on because there was nothing there holding the soil together, it was bare. And when we're looking here, if you can just come and have a look here, you'll see we've got quite a lot of blackgrass. Consistently, this plot where we've had no cover crop growing, we have experienced much higher levels of blackgrass, and I think generally you'll look at this plot, a lot of the blackgrass is actually down below the heads this year, and we're probably getting somewhere around about 125, 150 heads a square metre in here consistently each year. Okay, so we're now stood in system 3, and the only difference between system 3 and system 7 is that this one had a cover crop established last autumn. Okay, now the cover crop that we put in here was the specifically developed for this situation where we've got blackgrass issues, and it consists of a black oat and phacelia. And importantly, it's only sown at a fairly low density. We want to leave open spaces in and amongst the cover to allow blackgrass to grow. If we'd put a much bulkier cover crop in here, it would have purely just swamped blackgrass out, and then there's a danger there that the blackgrass would actually come back and haunt us in the springtime. So we've allowed blackgrass to grow in and amongst the cover crop, and in the early stages of growth, the black oat and the phacelia they're quite slow in the growing, so it's letting blackgrass get established, and then the black oat really comes into its own and starts to really get those roots down and start to put on a little bit of biomass. Very noticeable through the autumn and the winter time that when we walk across this plot, compared with walking across system 7, we're getting much better water infiltration here as to where we've just got no cover crop growing on system 7. those roots, particularly the black oak, are really getting down there and letting the water get through. I'm not going to talk about soil health because my colleague Chris will talk about those details. Now then, very importantly, when we get to springtime, it's important that we terminate these covers quite early on, and our best termination dates have always been pre-Christmas. We consistently would get around about 1/2 ton a hectare more than on any of the other plots. This particular plot here, the termination date was probably nearer the end of January, early February time, but it allows that cover to really start to die down, and any blackgrass that may have been shaded, we'll make sure that we capture those nearer the time of drilling. Then when we come in with a direct drill, in this case this was sort of round up towards the end of March time, what is very noticeable between system 3 and system 7 is that where we've had that dead cover here, it's holding the soil together much better in system 3 than system 7. And we don't get the same amount of soil movement going on, even though we've used the same drills. And I think really the plot speaks for itself. When you're looking in amongst it, there is far less blackgrass in here. We consistently record sort of levels around about 3-5 heads a square metre, compared with 125 where we haven't had a cover crop.
So Neil, from a blackgrass point of view at Project Lamport, it's probably fair to say we've been very successful with the approach we've taken.
Absolutely.
Yeah. So that black oak and Phacelia cover crop, the open nature of that, trapping the blackgrass, made a massive difference to blackgrass control.
It really has, Mark, yeah.
Brilliant. So the last thing that I'll often get questions is about the benefit of the plough, and I was a big fan of the plough, but we stand here with a plot of spring oats. And this plot last year, if we think back to when we were demoing it, this was winter wheat that made that last plot with blackgrass look almost embarrassing. It's had a huge amount of blackgrass, and what we've done here is exactly the same as you've described with the spring wheat, but we've planted spring oats instead. And even though we haven't ploughed, we've come from an absolute disaster, into a situation where we've got a nice crop of spring oats, employed the autumn cover crop, and then direct drilled spring oats, and we've still achieved a really good job on blackgrass.
I think this is truly remarkable, and certainly last summertime when we were discussing our tactics, what we were going to do in this, I was a little bit, my gut reaction would have still been to press the reset button and plough. But I think this has even proved to me now, in my, all my years of experience, that I think ploughing is probably the wrong thing to do now from a blackgrass point of view, unless it's match ploughing, and how many farms truly can carry out match ploughing. But this is just remarkable, and there's been no ploughing here, just purely working on the cover crop, the black oak Phacelia, and then taking on board the principles that we've learnt at Lamport over the years.
Great, thanks. So now we'll hand over to Chris to talk about soil health.
Hi, I'm Chris Martin. I head up soil health for Agravista, and I'm stood here in the middle of the systems at Project Lamport. You'll have heard Project Lamport was designed specifically to control blackgrass in these difficult situations. But over the 7 years of Project Lamport, what we've also seen is some of the techniques we've used to control blackgrass so successfully have also had some big effects on soil health. For example, moving to a more diverse rotation in both terms of time and species has had a really positive effect on soil biology, as has the introduction of cover crops. And what we're trying to do with cover crops is maximise the use of our most valuable resource, the sun, and actually turn this into soil biology in the ground by using sun-powered roots to actually naturally structure our ground and feed the biology. And what we've seen very clearly here at Project Lamport is where we've got more roots, we've got more biology. And from an analogy point of view, if you owned a solar farm, would you switch it off for 6 months of the year? Because that's essentially what we're doing by having bare ground before the likes of a spring crop or a late autumn crop. So having a cover crop in there, making use of that sunlight is absolutely key. Another key finding here at Project Lamport has been the lack of soil movement. That's had a really positive effect on our soil health. And what we've tried to do at Project Lamport when we've tried to establish our commercial crop is move as little soil as possible so we're not setting off blackgrass. And that's been really key. But one of the things we've tried to do when we've created our cover crop in the first place is try and make the blackgrass grow amongst our cover crop. So we've tried to set the blackgrass off with our cover crop so we can trap it and then destroy it with glyphosate. And one of the issues here is that's involved a lot of soil movement. And at the start of the project, we used a power harrow or power harrow combination drills to achieve this. It did a really good job of setting off blackgrass and establishing our cover crop. So we had a really good kill of blackgrass. But it became evident after a couple of years that this excessive rotary movement from the power harrow had actually caused some detrimental effects on both soil structure and soil biology. So as the project's moved on, we've tried to move less and less soil, but we still wanted to try and get that chitta blackgrass. So we adopted a Vardestad carrier with a cross-cutter disc, which is designed to work very consistently, but very shallowly, and still provided us with a very good chitta blackgrass, but without the associated detrimental effects from the deeper and rotary cultivation. And that was really successful. And now we're at a stage where we've depleted that blackgrass population that we can direct drill both our cover crop and our commercial crop. And that's really what we're trying to do now. Our default setting is to move no soil unless we have to. And we're even at the extent now we're experimenting in trying to establish our cover crop by blowing it into the previous crop and then trying to establish it within the previous crop, so our only metal going into the ground for that whole year will be the direct drill of our commercial crop. And that has to be the ultimate goal for minimal soil disturbance. Now that will only work if we don't cause issues to our soil in the first place. And what's come very clear here at Lamport again is we need to make sure we minimise traffic and control traffic where possible. And when we do have to traffic, make sure we use controlled pressure so we're not causing problems to the ground. But inevitably, with the Great British weather, there are times when we are going to cause some problems to the ground. And at the start of the project, when we did have these issues with compaction, we were going in with some pretty aggressive machinery and ripping up this soil. And in hindsight, we're probably doing more harm than good. What we've learned throughout this project is as we've got more healthy roots growing in the soil, all we need to do when we've got some forms of structural issues or compaction is actually use a low disturbance tine just simply to stretch that soil and provide some fissures and pathways for our roots to go through and do what they're good at, natural restructuring. So a real key learning factor from Project Lamport is as long as we've got healthy roots growing in the soil, when it comes down to metal, often less is more. So just to summarise, Project Lamport has been a really successful project at controlling blackgrass, but also from a soil health point of view, it's been a really useful bridge to that gap between some of the science and some of the theory out there and what is actually practically achievable on farm.
So welcome to Project Lamport. My name's David Purdy, and for a couple of years now I've really been looking and studying the health of our soils here at the project. The project, as you know, has been running for many years and primarily focused around the control of blackgrass. And that's been done through the use of cover crops and spring cereals. And the observation has been that the cover crops has really improved the health of those soils. So here, using replicated science and replicated plots, we've been really able to try and measure the effects of those cover crops on the health of our soil. We've been running 2 replicated trials, one now currently in its second year, looking at different species of cover crops, looking at the use of tillage and soil disturbance and no soil disturbance. And then a second trial really looks at the effects that cover crops can have in a compacted environment. We know much of our soil is compacted today, and so we've got a big replicated trial here looking at compaction at 2 different pressures. And again, you're looking at soil disturbance and tillage and no disturbance as well.
Welcome to Project Lamport, AgriVista's key blackgrass project. I'm here with David Purdy, and we're going to basically talk about the trials that David's been now involved with for how many years, David?
Yeah, so we've been running these a couple of years now, Phil. So, and you know, if you remember, some of the objectives we were trying to look at really at the beginning was to see if we could drive the biology hard through this process of photosynthesis, getting the energy into our soils, getting the biology into our soil through primarily the use of covers. Soil health's great, but if it doesn't produce yield, so that's the other thing we're super focused on, is driving soil health, but also driving yield, and also the background to this whole project is make sure we don't lose sight of the control of background. We've pulled a number of levers here to try and just see what responses we get from them, but we've looked at, you know, a couple of really key things. We've looked at low disturbance technology, and we've looked at, you know, just levels of compaction that agricultural machines might provide into this soil. You know, just talk us through some of the sort of thinking really around the low disturbance work and some of the compaction work that we've done here.
Well, the driver, David, here was that me, for one, I can't actually point a finger to any good science that actually delves into the real situation where if we've incurred a problem, what's the extent of the problem, so hence the 2 tyre pressures, but having done that, then trying to understand how much or how little we've got to do to correct it.
Yeah. And I think you know, from the work we've done so far, it's quite clear that, you know, we probably both agree less is more in terms of moving soil, and low disturbance technology is critical here, but we're not really finding, by going deep or by going shallow, we're not really finding any significant differences. So, and what we found really is the critical area in our soil where roots really need help is around that 10 to 12 centimetre area. So just by lifting just underneath that area, we found that we're getting some really interesting results from very shallow low disturbance technology.
And that's on the back, David, of that really extreme late autumn, wet winter, wet spring. So these soils naturally are going to run together, they're going to be pushed back together. So I think quite rightly your hypothesis has been borne out. Okay, David, so in summary then, what would you say have been the key learnings so far in the project?
So I think, you know, looking at the use of steel, for example, Phil, you're very familiar with that, but we've learned that less is more, you know, and if we just give the roots of our covers an opportunity, they'll do more for us than we need to do necessary with steel. So there's that interaction that's been a key finding. We've definitely a key finding is with the covers, we're driving biology of our soil very hard, so we've measured that in different ways, but, you know, worm counts, for example, have gone up quite significantly in very short periods of time, so it's not taking a long time for that biology to respond. So that's been kind. With that, structure has also improved, so, you know, the covers have driven soil biology really, really hard. But we also learned that, you know, we need to establish them very timely and in an appropriate way, and also terminate them as well in an appropriate way. And so looking at establishment techniques is a key finding, really, I think. And then establishment of the spring wheat is also important, that we use low disturbance technology there. So I think if we can build some of those findings into a production system approach, I think it's and
prevention rather than cure in terms of applied pressures. Again, there's been some good learnings with low pressure technology being superb, isn't it?
Yeah, we can, you know, with the 9 psi, the low pressure technology using kind of VF tire technology, we can really hardly pick up any damage in terms of plant growth to that kind of technology. So that looks like a key finding, whereas at the higher pressures we can start to pick up now some detrimental effects to our plant systems. So
potentially then cost money to correct.
Indeed, yeah.